Welcome pre-cal students to the homework help video. Here's the assignment right here on the screen in front of you, and hopefully this video would be a help to you if you have questions on some of your homework. Let's start off with numbers 33, 35, and 37. We're looking at these functions and we're seeing if they're odd or even, okay? Well, first of all, it's very obvious that this function is symmetric to hold on one second please, I'm looking at the problems here in the book. Okay, it's very obvious this graph is symmetric to the y-axis. It's wrapped around the y-axis, and so remember, a function that is symmetric with respect to the y-axis is called an even function. So it's an even function. Okay, now is it also symmetric to the origin? Well, let's see. Let's take a look at a point like this right here. This would be a positive x and a positive y. So if this point exists, then there also has to be a point negative x, negative y down here, because whenever you have origin symmetry, opposite ordered pairs always have to exist, and this ordered pair does not exist on the graph. So no, we do not have origin symmetry. Okay? All right, number 35, we definitely have x-axis symmetry. There's no doubt about that. Actually, we don't, and I apologize, that's incorrect. We do not have x-axis symmetry. In order for us to have x-axis symmetry, it would have to look like this, in which you have identical points on both sides of the x-axis. But let's check for even and odd. First of all, remember, if you have y-axis symmetry, that means the graph has to be perfectly wrapped around the y-axis. Well, that is not happening. Do you see this ordered pair right here? This is what? This is a negative x and a positive y. Now remember, if you have true y-axis symmetry, that means the ordered pair should exist in which you have a positive x and a positive y, same numbers. So a positive x and a positive y. So if you had true y-axis symmetry, this point here would exist, okay? And it doesn't. Also, another way to know that you don't have y-axis symmetry is if you were to fold this graph over, if you were to fold this like it was a piece of paper on the y-axis, would this part here fall exactly on this part over here? Well, no, it would not. This hump right here would land right here. It would not land right on top of this graph. So you do not have a mirror image excuse me on both sides of the y-axis. Now, origin symmetry we do have. Think about it. This ordered pair right here is negative x, positive y. So that means the ordered pair should exist, positive x, negative y, and it does right here. And then let's use another point. For example, this point right here is way over negative x and negative y. Well, so then the same ordered pair should be over here. Excuse me again. The same ordered pair should exist over here, only it should be a positive x and a positive y, and it is. Same distance over, same distance up. This ordered pair does exist. So yes, we do have symmetry to the origin, so we call this an odd function. Another way to know this is if you were to fold this on the y-axis, and then after you've done that, you'd have a half a sheet of paper right here, and then take that and fold it on the x-axis. The graph up here would fall right on top of the graph down here. It would be a mirror image, okay? And if you don't believe that, go ahead and draw it on a sheet of paper and try it, and you will see that is true. All right, number 37. Now, let's first of all check for y-axis symmetry. On number 37, well, first of all, I can see a problem right here, I believe. Let's go ahead and test some points. I know right here I would have 0 for my x, and then I would have a y value going up. So if this same point here were to exist, in fact, actually, I think it'd be easier to use a point that's not on the axis. Let's use a point right here. This point right here is negative x, and then it's up a positive y. So if I have y-axis symmetry, that means the same point exists, only it would be positive x and negative y. And it looks like we're good. Boom, we've got it. But remember, every point must be defined in this relationship. So I know this point here is y-axis symmetric to this point here, but here's the problem. See this point right here? That is not going to be y-axis symmetry to this point here, because this point right here that my pen is on right now is not colored in. It's undefined. Let me get a drink here real quick. And so we do not have y-axis symmetry. Also, another thing too to realize is if you were to fold this over right here on the y-axis like I've taught you to do, like it's a sheet of paper, would this line here fall right on top of this line here? No, it would not. And that's another way to test for y-axis symmetry. Now for origin symmetry, I think we'll start off with the folding paper method first. If we were to pick this up and fold this right down, fold the piece of paper on the y-axis like this, we would end up with a line that comes down like this. Okay, just like that. And then it looks pretty good. Now we have a half a sheet of paper over here on the right hand side right here. And if you were to fold that right here on the x-axis, it looks like this would fall right on top of this. But remember, we've got the problem here where this bottom line is undefined at this point right here. And so if it's not defined here, then we don't have true origin symmetry. You could also use the ordered pair method. I mean, think about it. We know that if I have an ordered pair here, we'll call it 0, comma, y. Then that means if this point exists here on this part of the graph, then I also must have the point that's negative 0, negative y. Now, of course, negative 0 is still 0, and negative y would be right here. And look, it's undefined. It's an open point. So no, you would not have origin symmetry, nor would you have y-axis symmetry. So this function is neither even nor odd. Okay, now let's get into the equations. We have 4 of these, I believe. Actually 5 of these. So let's quickly check for even and odd functions. Okay, first of all, we'll check for even functions. That means y-axis symmetry. So everywhere there's an x, I'm going to substitute a negative x. And we'll do this pretty quickly because they're not difficult. And here we go. If you take negative x to the third power, you'll get a negative x cubed times negative 3. That gives you a positive 3x cubed. And then you have a positive 2 and a negative x. That gives you a negative 2x. So, do I end up with, when I put a negative x in for x, do I end up with the original equation? No. So I do not have an even function. I do not have y-axis symmetry. But I'm going to use a shortcut here in this video today. I mean, now why should I have to rework putting a negative x in? Now I'm going to come here. I've already put a negative x in for x, right? Didn't I do that right here? And I already simplified it, right? Now to check for origin symmetry or odd functions, I would simply put a negative y in for y and a negative x in for x. Well, I already put the negative x in for x and I simplified it. Now I'm going to put the negative y in for y, and now I'm going to go through and change all the signs so my y is by itself. And when I do that, look what I get. I get the original equation, okay? The original equation. So with that in mind, I do have origin symmetry, which means I do have an odd function. Okay, moving on to number 41. All right, let's first of all check for even function, which is y-axis symmetry. Everywhere there's an x, I'm going to substitute a negative x. This should not take too long. A negative x squared is positive times 5 is a positive 5x squared. A negative x to the fourth power is a positive x to the fourth times 2. That's 2x to the fourth. Then bring down your negative 1. Over here I bring down my f of x. There. Everywhere there was an x, I put a negative x and then I simplified. Did I get out the original equation up here? Well, the answer is yes. Yes, I did, definitely. So I definitely have y-axis symmetry, so I definitely have an even function. Now let's check for an odd function. This is really a y, and so where the y is, I'm going to put a negative y. Now remember, you're supposed to put negative x in for x, but I already did that over here, and I already simplified it over here, okay? So now I put a negative y in for y, go through and change all of your signs, and obviously you're not going to have the original equation or the original function. So no, this is not an odd function. All right, number 43. Let me get a drink here. Okay, let's check for y-axis symmetry, or in other words, to see if it's an even function. Everywhere there's an x, I'm going to put a negative x. And now negative x to the 17th power gives me negative x to the 17th power. Does that match my original function? No, it does not. So I do not have an even function. Now let's check for an odd function. Remember, you're supposed to put a negative x in for x. I already did that. And you're also supposed to put a negative y in for your y. So I'm going to go ahead and put a negative y right here. Now we'll go through and get y by itself. Change all the signs. So a positive y equals a positive x to the 17th. That is, or that does match the original function. So we do have an odd function. We do. Okay, moving on to 45. Everywhere there's an x, I'm going to substitute a negative x. So I have 1 over negative x to the second power. And of course, when you square a negative x, you really get a positive x squared. Bring down your f of x, and look at that. We do have the original function, so yes, we definitely have an even function. We definitely have y-axis symmetry. Now let's check to see if we have an odd function. All right, and so we're going to substitute a negative x everywhere there's a negative x, and we're going to substitute a negative y everywhere there's a y. And so let's see what happens. Obviously, when you substitute a negative x here, we've already simplified that. And here we have a negative y, so we'll bring down negative y. Now go through and change your signs. So your y is positive, and your fraction over here becomes negative. That does not match. Let me get a drink of water here, excuse me. That does not match your original equation, so you do not have origin symmetry, so you do not have an odd function. And then lastly, number 47. Now this one's tricky because really what you have is y equals 8. Do you see that? And you really have nowhere you can put a negative x in for x. I would suggest that you have a deeper understanding of graphing, and just think about this for a second. If you have y equals any number, you should have learned by now that's always going to be a horizontal line passing through the y-axis at whatever y equals, in this case 8. Now I have a question for you. Does this look symmetric to the y-axis to you? Well, students, it does to me. Let's pick a point right here. Let's say that point is over 3 and up 8. Okay? Now remember, if you have true y-axis symmetry, that means you can change the sign of the x, not the y, and it should exist on this graph. So let's change the 3 to a negative 3. Does negative 3, 8 exist on this graph? Well, of course it does. This line constantly stays through the number 8 all the way across. And plus, another way to know that you have y-axis symmetry is, look, if you were to pick up this graph and fold it like I've taught you to do right here on the y-axis, would not this graph right here fall right on top of this graph over here? Sure it would. So we definitely have y-axis symmetry. We definitely have an even function. Now, let's check for odd function or symmetry to the origin. Let's use this same ordered pair, shall we? Let's say that 3, 8 is on this line, which it is. If you have true origin symmetry, you should be able to change the sign of both of those numbers, and that point should be on the graph somewhere. Well, let's see. Here's -3, -8, way down here. I mean, I'm being a little sarcastic, but I don't think that point exactly falls on this line up here. Okay, it doesn't. And plus, well, I'll just leave it there. But if you did the folding over trick, it wouldn't work at all. If you were to fold this on the y-axis, then this part of the graph would fall right on top of this. But then if you were to fold it on top of the x-axis, this would fall over here on top of nothing. Okay, so we do not have origin symmetry, thus we do not have an odd function, but we do have an even function. So in closing, I want to remind you students again what the definitions are of even and odd functions. Okay, an odd function is when a function has symmetry with respect to the origin. Remember, origin starts with the letter O, odd starts with the letter O. An even function is a function that has symmetry with respect to the y-axis. Okay, and so you need to know that in working these problems. Okay, I hope this homework help video has been a help to you. If you have any questions, call or email.